Okay, so now for part B, my job is to minimize this area function on the specified domain. So I can write down the area function again. That's a w squared plus 8 quantity squared over 4w. And my domain is given to me. And I want to minimize. So in order to minimize, I need to take the derivative. If I take the derivative of this, I'll have a low times a d high. Don't forget your chain rule, that will throw you off. Minus a high d low over a low squared. Now we got to be careful when we do our low squared that we actually square the entire denominator. Now my job is to figure out when this is equal to 0 and when this is undefined. Well, the undefined will occur when the denominator is 0, and that happens when w is 0, so we don't get that because it's not in the domain. The second part, getting the top equal to 0, is going to be a little more challenging. So what we're going to do is we're going to think about factoring this top. So my goal is to set it equal to 0 or undefined. We've already figured out this happens when w is 0, which is not allowed. The other one will come from when the top equals 0. So we're going to write down that top only and kind of ignore the bottom since we've already dealt with it. I have a 4w times a 2 times a w squared plus 8 times a 2w minus a w squared plus 8 quantity squared times a 4. I need that to equal 0. Now, typically what happens is people who have not practiced this problem will multiply all of this out and they'll end up with w to the 4th. So they'll have this big long polynomial of a 4th degree, and then they're going to try and factor it. That is very time consuming, very difficult, and people will sometimes spend 10-15 minutes just wrestling with this to do it by hand. And that process is very unnecessary if you actually use the fact that this is partially factored for you. You can see that there are some common factors in both of these big terms. We have a w squared plus 8 in both of them, and we have a 4 in both of them. So we can pull those both out and factor much more easily than if we multiply everything out and then combine like terms. So if I do that, I'll have a w squared plus 8 and a 4 that gets pulled out. If I look at what's left on this term, I lost the 4, I lost the w squared plus 8, so I'm left with a 2w and then another 2w. That's a 4w squared. Over here, we can see that I lost everything except a w squared plus 8. And this is what needs to equal 0. So if we look at our terms now, we can have a 4 equaling 0, which doesn't happen. We can have a sum of squares equaling 0, which doesn't happen. Or we can have this interior, which is 3w squared plus 8 equals 0. And that's the one that will generate, minus 8. This is the one that will generate our 0 for the derivative. If I isolate w, I'll get an 8 over a 3, a square root. Notice I'm only taking the positive root because I have to stay in the domain. Now if you look on my key, this is a 2 root 2 over a root 3, and I think I simplified that by rationalizing and got a 2 root 6 over a 3. So now we're going to verify that a prime on our domain at that 2 root 6 over 3 actually changes sign. So if we look carefully, we want it to be a minimum. So I would say probably 1 is smaller, because the square root of 8/3 will be larger than the square root of 1. So I can plug in a 1, and this will be positive, this will be positive, and this will be negative. So I'll have a negative result. After that, say a number bigger than this is maybe 2. No. Yeah, because this is less than 4. So we could say w is 2. That'll be smaller than this, but bigger than this. So if I plug in 2, I have a positive, and a 12 minus 8, that's also a positive, so I get a positive. So we can see that a prime had a 0 and changed from negative to positive. So we can write A has a min at x equals 2 root 6 over 3, or actually that's a w, excuse me, because A is continuous and A prime changes from negative to positive. And we did not have to find the area, we just had to find the value of w. So, we're done.